Okay, let's have a look at a limiting reagent problem. Now, when you're doing mass-to-mass stoichiometry, we tend to think about the conditions in mass-to-mass stoichiometry as something quite ideal. So let's say we have X amounts of this substance and you add it to Y amounts of that substance. How much of Z amounts of substance would you make, considering they all actually react and everything reacts in the proper proportions? That tends to be what mass-to-mass calculations do. However, in real life, that doesn't actually work that way. So we have this thing called a limiting reagent, which is usually the reactant or the reagent that usually gets used up in reaction, and we have every other reactant in solution, we call them in excess because there's more of it than is needed in the reaction. The limiting reagent gets used up and anything in excess sort of stays in solution. So you have the thing that's in excess and also the products and no more of that limiting reagent. So let's have a look at this reaction here. We have 60 grams of tetraphosphorus diethoxide. You react it with 60 grams of water to make phosphoric acid. Now phosphoric acid is that nasty stuff in Coke, so yeah, be careful, it's quite bad. But let's have a look at the actual reaction. So we have tetraphosphorus, so P4 diethoxide, O10, and we react that with water, and we produce phosphoric acid. I'm going to let you have a go at balancing this equation. I want you to have a go at it, so pause for now and have a go at balancing this equation because that's also a very important skill. Alright, welcome back. Let's have a look. So I've already got a balance. We know that for 1 mole of P4O10 you have 6 moles of water and you'll produce 4 moles of phosphoric acid. Now in these proportions, this actually tells us the molar ratio, so the ratios of the number of moles of products and reactants actually tells us how much gets used up in the reaction. For every 1 mole of our P4O10, it will use up 6 moles of water and to only produce 4 moles of phosphoric acid. So let's say we have, say, 6 moles of that and 6 moles of that. How many moles of phosphoric acid are we going to get? We know that all those 6 moles in the reaction get used up. So we're actually going to have none of that left because that's all going to get used up. Now and we're going to have 4 moles of our phosphoric acid, and we know that for every 6 moles of water you only use 1 mole of P4O10, so we're going to have 5 moles of that left. So at the end of the reaction we're actually going to have 5 moles of our P4O10 along with 4 moles of phosphoric acid. Now when we actually do in terms of masses, it tends to go the other way. It tends to be the thing that's the least abundant in the reaction because it tends to be the heaviest. So this compared to water will be incredibly much heavier compared to water. So let's have a look at the actual reaction. We have 60 grams of our P4O10 and 60 of water. So let's first find out how much of our reactants we do have. So first let's have a look. What's the molar mass of P4O10? And I'll let you pause now so you can calculate it. Get out that trusty periodic table and calculate it now. So you should have calculated at 283.89 grams per mole. So if we know that and we know the mass of P4O10 is 60 grams, so we know the number of moles of our P4O10 should be 60 over 283.89. I'm going to let you go ahead and actually calculate that for me. And what you should have gotten is 2.11 by 10 to the negative 1 moles. So that's how much, from the 60 grams of P4O10, that's how many moles we have in the reaction. Let's figure out how much water we have. So we know that the molar mass of water is 18.016 grams per mole, and we have 60 grams of it, 60 grams of water. So our number of moles of water is just 60 over 18.016, which should give us around about 3.33 moles. So in terms of proportions, now let's analyze it in terms of proportion. If let's compare how much P4O10 will actually use if we had just this much. So let's first compare the number of moles of water we'll actually need. So we know that the number of moles of water that we'll actually need is 6 times the number of moles of our P4O10, which is around about 1.26 moles. Now, if we go the other way, how much P4O10 we'll actually need if we had compared to the number of moles of water, which is a 6th times the number of moles of our water. So this should be around about 5.55 by 10 to the negative 1 moles. So if we actually compare these values, if we compare these numbers to how much we actually have, so theoretically, if we used up all our P4O10, we would only use 1.26 moles. Now that is far less than how many moles of water we actually have, and we can confirm this because if we have a look over here, 5.55 by 10 to the negative 1, that is way more. That is a lot more than what we originally had, which is 2.11 by 10 to the negative 1. So clearly we can tell that our phosphoric acid is the limiting reagent, and our water is going to be in excess. So let's now answer the rest of the question. Okay, so here we clearly can find out that because our P4O10 is actually our limiting reagent, we're going to have none of that left after the reaction. However, we're going to have some water left. Let's find out exactly how much water we're actually going to have left. If we think about it, this is actually how you're going to do it. You get the number of moles of what is actually of how much water you have of the reactant in excess, and you take away by the number of moles that are actually used. Now that number will just number of the reactant in excess, and we get that from here, which is 3.33 moles, and the number used will be compared to how much we'll actually need compared to how much P4O10 we have, which is 1.26 moles. So whatever's left over will be actually how much of it we have, how much water we have left, which is around about 2.08 moles. So we can figure out the mass of our water will just be 2.08 times 18.016, which is just the molar mass of water, which you get about 37.47 grams left over from that 60 grams of water. And let's find out very simply how much of our actual reactant will be produced. I'm sort of running out of room here, so I'm going to have to put it up here we know that the number of moles of our phosphoric acid is 4 times. Now here, in order to calculate our products, we need to compare that to what was actually used up, which is our phosphoric acid. So it's 4 times our number of moles of P4O10, I apologize, which is around about 8.34 by 10 to the negative 1 mole, and so the mass of our phosphoric acid is just the molar mass of phosphoric acid, which is the molar mass of phosphoric acid, which is about 98 grams per mole, times that above should give us around about 81.70 grams of phosphoric acid.